Hi everyone, I'm Chen Hao, one of the lead CAs for CS128 Honors. Today we're going to go through lecture 3, which is the second part of the Rust basics. So what we'll cover today we'll be talking about some Rust programming basics. Um, we'll first cover the functions and the syntax for how to define a function. We'll cover compound data types and we'll talk about vectors. So in this lecture, the optional reading is actually chapter 3 and chapter 8 of the Rust book. Chapter 3 is an extension of last week's lecture, and chapter 8 will cover 8.1 will cover vectors, which we'll discuss later in the lecture. So the first thing today we are going to talk about is functions. This is the syntax for defining a function in Rust. So notice here that every time we define a function, we start with the fn keyword, and then the function name. So here we have the function name is +1, and then between the two brackets here we have our parameters. So parameters are like the arguments that you give into the function. A lot of people use the word parameters and arguments interchangeably. So in here we have two parameters. One parameter which is like a variable of name x and of type i32. So we define parameters in the functions like this, where we give the name and the colon followed by the type. Lastly, with this dash arrow thing, um, after that we have the return type. So for example, this function +1 takes in two parameters, x and y. X is an i32, y is a boolean, and it returns an i32. So here we can see the body of the function. If it's y, which is if y is true, then we return x +1, else return x +2. So these are the key components of a function definition. Now moving on, I'm going to zoom in on the return portion of a function, like the value that it returns. So again, we have the same function called function +1 that takes in two parameters, x and y, and returns an i32. So notice here that I only wrote x +1 here. So this actually means that I'm returning the value x +1. And in this case, I did not write the return keyword. I did not write return x +1 semicolon as we would expect. Instead, I'm just writing x +1. So how is this possible? We need to zoom out a little and talk about Rust as a whole. So in Rust, there's this thing called a statement and an expression. So everything is basically a statement or an expression. A statement will be an instruction, like a line of code that tells the program to do something, but it doesn't return any value. So for example, when we have let x equals to 5, semicolon, this is just a statement that assigns fine to the variable x. On the other hand, we have this kind of things called expressions. And expressions always evaluate to a specific value. So for example, x +1 is an expression. And in Rust functions, we can do implicit returning, and basically it returns the value of the last expression in the function. Or basically in this case, if the last line of your function is an expression like this, remember that an expression evaluates to a value, it will simply return this value. So this is a interesting way of implementing the return statement in Rust. And in most Rust programs and functions, you will see that this is the method that is used to return the value, where you just write the expression at the last line of the function. So this is considered the more Rust way to write the return type. Now moving on, we recall that last lecture we talked about the four primary scalar types in Rust. We have integers, floating points, booleans, and characters. So today we're going to talk about this new thing called compound types. So Rust has two primitive compound types. One is tuples and one is arrays. And Rust also has another compound type that is not a primitive, which is called the vectors. Primitives are constructs that the compiler directly recognizes, so you don't really have to create like a new um, class or object or function to be able to create a primitive. So we'll understand more about it as you see the examples. Those, the first compound type we'll cover today is tuples. So tuples are essentially groupings of values, and the interesting thing that is that within a tuple, so for example here we have the first tuple. A tuple is defined by a bracket like this, with comma separated values inside the tuple. So the interesting thing about tuples is that the values in the tuple can have different types. So for example, in this tuple 1, we have three elements. The first one is an I32, which is what Rust defaults to an I32. The second one is an F64, like a float, and the last one is a string reference, right? It's like a string with the double quotes and everything. So we can see that this is one tuple of three elements, but all three elements have different types. So with tuples, this is possible to declare elements in a tuple of different types. Another example of a tuple here is here. Again, we define it within the bracket. With the comma separated values, we have a boolean followed by a number. So in this case, it will be an I32 and a boolean. Now, as we learned about declaring variables in the last lecture, there are always two ways to declare a variable. One is like this, where I don't explicitly specify the type, and the other way is like this. So here I create another tuple. I explicitly specify that the type is U8 followed by a bool followed by an I32. In other words, I'm creating a tuple of length 3 that will have these three types in there, and then I initialize it to 8, true, and 20. So whether or not to do type annotations, the rule of thumb is that if the compiler can figure out the type just from our declaration here, we don't actually have to do the type annotation. So the type annotation is important when it's ambiguous. For example, for this 5, instead of it defaulting to I32, I want it to be an U8, like in this case. I want this 8 to be a unsigned 8-bit integer. So in this case, we have to declare the type when it's not the default value, or when it's not clear that the compiler is able to guess the value that we have from the declaration. So the last thing is that tuples are of fixed length, and once they're declared, it cannot be expanded or shrunk. So there are two main ways to access tuple values. So example here, we have the first tuple with 5, 3.0 and the string chicken. So the first way is called destructuring, as we've written here, and the syntax looks a bit like this. So we let bracket xyz equals to tuple 1. So this xyz almost looks like a tuple in itself, but what it's actually saying is that I want to assign the values of x, y, and z to the values within tuple 1. So in this case, x will be 5, y will be 3.0, and z will be the string chicken. So in this case, if I try to print line y is y here, it will actually print y is 3.0. Another way to access tuple values is through indexing. So for example here I have let number equals to the tuple 1, and index the element at index 0. In this case I'll get 5. So number will become an I32 of value 5. Another way is to another example of using indexing will be I let word equals to tuple 1.2. So index 2 is 0, 1, 2 will be the string chicken. So if I print line here, actually it will show number is 5 and word is chicken. So these are the two key ways to access a tuple value. Now the next compound type, before we move on, this is just an important thing to take note of. There's a special tuple, it's called the unit tuple, and it looks like this. So for example, there's a variable called unit tuple, and it looks like this, which basically is just a tuple without any value, like empty tuple. So actually, in Rust, it represents an empty value and an empty return type. So actually, when we have functions that don't actually have a return type specified, it actually returns a unit tuple. So you don't have to be too concerned about this. It's just an import, like it's just a thing that you should know, that there's such a thing called a unit tuple, which is basically an empty tuple, and you might encounter it as you read the documentation and run some other functions. So the next compound type that we're going to go through is arrays, and this is basically almost exactly the same as arrays that you have in other programming languages. So there are few ways to initialize an array. So okay, before we begin, arrays are lists of values of the same type. So unlike a tuple can contain different types within it, but arrays all have to be the same type inside the array. And once arrays have a fixed length, so once they are declared at the compile time, you cannot really change the length of an array. So for example here, I have an array that is declared with initialized to the values of 1, 2, 3, 4, 5. So this is like the simplest way to declare an array. As we've discussed before, every time we initialize or declare a variable, we can do it with explicit type annotation like this, or without. So in the second case, we do an explicit type annotation where we do, so this is the syntax for the type of an array. So it means that the elements inside will be of type char, and there's 3 elements. This is the length of the array. So this is the syntax that we use to define the type of an array. So the last way to initialize an array is using repetition. So for example, in this case, it means let array tree equals to the value true repeated 4 times. So I just repeat again, this means that we take this value and repeat it this number of times. So in this case, array tree would actually look like this: true, 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 true. Notice that in this case we didn't have to use a type annotation because the compiler can infer that the type we're using here is a bool. So accessing array values is very, very straightforward. It's almost exactly the same as the common languages that you know in C and C++. To get the first element, I just index 0, second element I index 1, and then you just index the value like that, right? And if I print number 1 is this, this actually will come out to number 1 is 1 and number 2 is 2. So yeah, basically it's the same as other languages. Do note that if you try to index an index that is out of bounds, it will panic. So I will show an example of this in the code demo after this. So lastly, the last thing I want to talk about is vector. So vectors are special because just now we talked about tuple and arrays, and remember we said that tuple and arrays are primitives, right? Like as we've declared earlier, we can directly create a variable that is an array or variable that's a tuple using just the bracket statement or the square brackets, right? But actually, vectors is a special type of collection in Rust. It's almost like an array in the sense that in the vector, every element has to be of the same type, but actually the difference is that it's an array that can be resized. And this is because the vector is stored on the heap instead of the stack. So don't worry if you don't know what this means. This will eventually be covered in 128. But the key idea is that a vector is basically like a special array, and it can be resized. That means we can add values to it, we can remove values from it, and the length of the vector will change and it can be dynamic. So let's look at an example of how to initialize a vector. So as I said before, so the vector is a collection, it's a special type, it's no longer a primitive. So the vector itself there's a vector class or a vector object in Rust, and we declare it like this. So we let the name of the variable my vector, and the type is actually capital V VC vector. And notice that we have this new notation of the triangles, open and close triangles, and this specifies the type. This specifies the type that we'll store in the vector, and we initialize it with this method vector new, and this initializes a new vector of type I that stores i32 values. Another way to initialize a vector is to, again like this, your vector, and using this is called a macro. Like every time you see a question exclamation mark like this is actually called a macro. Can think of it like a special kind of function, and we won't elaborate too much into this, but basically this will initialize a vector with elements 1, 3, 5, 7. So now that we've initialized the vector, we want to talk about how we insert into it. And here, notice that I've declared the vector again with vector new, and notice that I've used the word mute. So if you recall from last lecture, mute means that I'm declaring this variable as mutable, meaning that it can be changed. So for example, in this case here, I'm writing my vector dot push 5, and this is the method that we use primarily to insert elements into a vector. So here it will insert the element 5 into the vector, it will insert the element 7. So actually when I print the vector out here, it will look like this: 5, 7. Now I'm going to talk about how we access the elements of a vector. So this is similar to the last slide where we push 5 and 6. So now our vector itself has elements 5 followed by 6. So the first way is to use indexing. This is completely similar to the array where we use a square bracket and we index the value 0. So in here, when we print line A, we'll get 5 because 5 is the first element of the vector. So using traditional indexing like this, where we give the index in the square bracket, the code will actually panic if we index past the length of this array, and we will give a demonstration of this in the code demo later. But actually there is actually a safer way to do this. But before we do that, I need to go on a detour and then introduce this thing called an option. So this is the official definition of an option in the Rust documentation. Don't worry if you don't understand what all this means, but the key thing you need to get out of this is that an option is a special type, and it can be a none or it can be a sum. So this is going to sound a bit confusing, um, but basically an option is a special type, and it can be one of these two instances at the same time. So basically, um, when I get an option, when I get an option as a type, it can be a none or it can be a sum, right? And it can't be both at the same time, but it's definitely one of the two. So none means that there is no value. It's basically like a null or null pointer that we have in other languages. And sum means that there is a value associated with it. Is think of it as like you're wrapping a value. So a concrete example would be, let's say we have a variable of type option I32, right? That means um, this option I32 type, this variable instance, can actually be a none, which means there's nothing, or it can be a sum of 5, which means it's wrapping the value 5. So um, don't be too worried if you don't completely understand this right now. This is actually a pretty interesting aspect of Rust that we will cover more deeply in a few lectures from now. But the key takeaway that you need to know about this option type is that basically it, it can be one of these two types. It can be one of these two variants at any point in time, and represents having something or having nothing. So why is this important to our discussion of accessing a vector? Is because in Rust, the safer way to actually access the elements in a vector is to use the get method. So again, we initialize the same vector as just now, but now instead of using indexing with a square bracket, we use myVector.get, and this will be the index 0, right? And actually, when we do myVector.get, this get function returns an option type. Remember that we talked about an option type here. This get function returns an option type, which means when I give it a valid index, it will give me a sum, like SOME sum, like sum of with the value wrapped inside. So when I do get 0, I will have sum 5 wrapped inside. And if I get an index that is out of bounds, instead of panicking, the code will just return me a none. So in this case, A will be none. So again, don't be too worried. I'll demo this in the code demo right after this. But the key takeaway is that when we use the get method, A is an option type of either sum or none. And because of that, the code doesn't panic. Now it puts the responsibility on the programmer to check if it's a none type. And this is one of the safety features in Rust. So to recap, we have covered a few new compound data types. There's tuples and arrays, which are primitives, and vectors, which is a collection type. There are two ways to initialize it, using the new and also with the macro. We can push to add elements, and to access we can use indexing with the square bracket or using the get method. So now I will demo this vector using both methods, right? So here here is my setup. So on the left here that you see, we have the code, and on the right here I will run the program. So here again, I've defined the vector as we've seen here, exactly the same as in the slides. We have a my vector, and then we push 5 and 7 into it. Now I'm going to use square bracket to index it, and I'm going to index 0, right? So I'm going to run it, and this will give a value of 5, right? Now if I try to index let's say I try to access the element at index 9. We know that this does not exist because the vector only has length 2 and is index 0 and index 1. So now if we try to access the element at index 9, let's see what happens. So let me save the code, and I'm going to run it here. So let's take a look. So we can see that, now instead of having returned the value, it says that the thread main panicked, at line 7, column 21, and the problem is index out of bounds. The len is 2, but the index is 9. So notice that the thing to take note here is that this is actually a Rust safety feature. So every time you try to index an array or a vector in Rust, during when the code is running, it actually checks whether the index that you're trying to index into the array is a valid index. And if it's not a valid index, instead of accessing the array beyond the bounds like in other programming languages, it will actually panic and stop the program running. So this is actually a safety feature, and it prevents certain like problems like buffer overflows that you get in other languages. Now we're going to try using the get method. So for example here I use dot get 0. Okay, let me save the code. So just to recall, when we use dot get, we get, in return we get an option type, remember? So a will now be an option type, and we're going to print out a here. So remember that an option type can either be a sum or none. So in this case, since we're getting index 0, which is 5, we expect to get a sum that's wrapping a value 5 inside. So let's check it out. So I'm going to run cargo run, and see in this case that we are getting sum 5 in there. Okay, this will be the same if I run index 1. Right, let me save and let me run it. Cargo run. Now I'll get sum 7 because I'm getting index 1. Right, so all this is expected behavior. Now what happens if I try to index an invalid index? So for example, let's put index 10, and let's save the code. So we're trying to get index 10, which obviously doesn't exist. So what happens here? Let me run cargo run. We see now that even though we're accessing an index that's out of bounds, the code did not panic, it runs fine, and it returns a type none. So again, this a is of type option, and in this case when we're getting an index out of bounds, it just returns none instead of panicking the code. So this is again a safety feature in Rust. So back to the slides. The announcements part, homework 1 is already released, and it will be due on this Friday, September the 13th, and it will be due at midnight. And if you find some of the content of the lecture confusing or you don't understand it, feel free to approach us at office hours, or if you need help with the homework, we have office hours almost every day, and the Tuesday office hours are in person. So have fun coding Rust.